This is problem 9. Another example of a linear equation in one variable that has fractions. So that's where we start. We're going to make the fractions disappear by multiplying both sides of the equation by a multiplier that will cancel the denominators. And in this case, that multiplier would be 3. I'm going to multiply both sides of the equation by 3, which means here I have to distribute this multiplication of 3 times both of those terms. I have to take 3 times the 3x plus 3 times that fraction and now let's cancel before we multiply with the fractions, and here we're just multiplying whole quantities. So 3 times 3x will be 9x, plus the 3's will cancel to 1, giving me just plus those two terms, plus 2x minus 3 equals, and again, the 3's cancel to 1, just leaving us 12x plus 3. Well, let's go to the next step, which is to see if there are any like terms in the expressions that we can combine. And I do have like terms here, don't I? 9x plus 2x is 11x. I want only one term with the variable. I have two terms right here with the variable. So I want to make one of those disappear. I'm going to do that by subtracting 11x from both sides of the equation. That disappears into 0, giving me negative 3. 12x minus 11x will be 1x. And now I want to isolate that variable term. I want to isolate the variable term. Right now it's in conjunction with a constant term on this side of the equation, so I have to get rid of that constant term. So I have 1x, or x. We can write it either way. I owe 3 more. That's the same as owing 6. And we've found our solution. If we were to take negative 6 and place it back in the equation in place of x, the left-hand expression's value would be the same as the right-hand expression.